All right. Let's do some review first of all on how to express something written in words, express it using simples, and something that is given in simples, how would you express it in words? So the true mean, express the following using expressions. The true mean is between 112.5 and 127.6. True mean, guys, means the population mean. Here's the simple. And if you just want to write down what he means here, you just write it down like this. Next one. The proportion of students is between 45% and 47.8%. Would a student suggest a letter for the proportion? A simple, what would you use? Give me a suggestion. P, very good, Yaman. P, which is 45%, change it to a decimal if you like. And change this to a decimal will be 0.478. You need to understand, guys, that proportion means a percent also. So if I want to say what proportion of students are present today, I mean what percent of students are present today. It's the same thing. So let's say I have 18 or 19 out of 28. I just divide 19 by 28 and change it to a percent. This is a proportion out of the total, and it is a percent. So please keep in mind, when he asks you for a proportion, it's a percent, it's a probability. In your chapter 5 assignment, he says what proportion is more than whatever number. It is what the probability that X is more than that number. It's exactly the same thing. So proportion, percent, probability refer to the same thing. Next one. The mean age is between 21.15 and 23.5. Mean, guys, this is the simple, mu. This is population mean. And X bar, guys, is not a population mean, it's a sample mean. Keep that in mind, please. Sigma is the population standard deviation. Just to refresh your memory. And S is the sample standard deviation. Just a reminder. Okay. Interpret the following in words. Can someone interpret the next one for me in words? How would you say this in words? Yes. The mean is between those numbers. Okay. True mean. That sounds good. Is between 28.5 and 30.2. Good. What about this one, guys? The true proportion is between. Usually when you write a statement about proportion, it's good to change it to a percent. So just do 45% and 51%, guys. Okay. Who can help us now find the midpoint of the interval 30 to 37? First of all, let me tell you what an interval is. An interval is a range of values from to. So the interval 30 to 37, all the values from 30 to 37. There are infinitely many values. It's continuous case. It's so there are infinitely many numbers, 30.1, 30.2, 31.5, 31.56, so on and so forth. Oh, true proportion is the same thing. The true proportion or the true mean is this true or proportion, but they usually sometimes you see the word true just to tell you it's a population proportion. So true means comes from population. So midpoint, guys, anyone want to help me with the midpoint? Should be easy. You already did the midpoint of a class in chapter 2. So what do I do to find the midpoint of the interval 30 to 37?
You add them and divide them by 2.
I agree. You will see, guys, it's all going to be of use to us. This is all introduction to what's going to come later. Okay. Let's see. No, I think we cannot do the rest before I introduce confidence intervals. So let's do an introduction to confidence intervals right now. Okay. An interval, guys, as I told you, it's a range of values from a certain value to another. Let's say, guys, we wanted to estimate the age of the mean age of students at Henry Ford College. So we collect a sample of 20 students. Let's say one of you did the task, collected a sample of 20 students, and then computed the sample mean of those 20 students. And the sample mean turns out to be 21.2 years. Can I make a conclusion that the mean age of students at Henry Ford College is 21.2? Yes or no? So we wanted to figure out the average age of students at Henry Ford College. We surveyed 20 students. And from the 20 students, we got a sample mean of 21.2 years old. Can we make a conclusion that the average age of students at Henry Ford College is 21.2?
Yeah.
Okay, let's see in the chat, guys. Is it a yes or a no? Anyone else?
No, because there might be an outlier.
Okay. What else, guys? Any other answers? Okay. Let me ask you a question. What about if we have another students do the survey and these students do a different 20 students? Do you think this student is going to come up with 21.2 as well? Yes or no? The answer is no. You agreed with me before when we did samples, guys, that the average of the sample can change from one sample to another. So if we have another students go out and survey 20 students and get their ages and do the average age, it doesn't have to be 21.2. It might change. It might be different. And then a third students will survey 50 students, and then he or she is going to get a different sample mean. So actually, guys, the sample, unless if the sample is very, very large, the sample does not really represent exactly what happens, just to the mean of what the actual mean is. So even if 20 students go for the task and each of them survey 20 students or 30 students, whatever, each student, I can assure you guys, they're going to get a different result. They're going to get different average. So let's say we have a students go out and they got the following. One student surveyed 20 and he or she got an average of 21.2. Another student surveyed 25 students and got an average of 21.5. A third student went out and surveyed students and he computed an average of 19.5. A fourth student did and got 20.7 years old. Which one we're gonna use, guys, to represent the population mean? Actually, none of them, because none of them is actually the population mean. The only way to find the population mean is to survey the entire population and figure out the mean. So when you do a sample, yeah, it will estimate the mean, but it does not give you the actual population mean. But what about, guys, if I tell you that I think that the mean is probably between 18 and 22 and included all of those numbers in there? Would this be a valid statement here to say probably the mean with some confidence level is as low as 18, is as high as 22? Would that make sense? That should make sense, guys. You're saying that you suspect that the mean could be between 18 and 22. You didn't say it's a 21.2. You didn't say it's 20. You didn't say it's 19.5. You didn't say it's 20.7 and so on and so forth. But you're making statements said, I think that the mean probably between 18 and 22. This 18 to 22, guys, is called a confidence interval. And this is what I'm gonna try to show you how to construct today by hand and by using the calculator. So let me tell you what the word confidence means. If I tell you that I am 100% confident that your score on the next test is gonna be between 0 and 100%, is this a valid statement? Yes or no?
Yes.
It is a valid statement, but does it have any value? You all know that the score is between 0 and what, 100. So when I say 100% confident, that means I'm very certain that this is what's gonna happen. But if I say here, I couldn't say I'm 100% confident that the true mean of the true mean age of a student is going to be between 18 and 21, because there could be a sample, guys, that where the average was less than 18. I don't know here for sure. In order to, unless if you know for sure, you cannot make a 100% confidence level statement. What about if I say I'm 90% confident that your score on the next test, it's gonna be between 50 and 100%. That probably is a valid statement. I'm not saying I'm 100% sure. I can never be 100% sure. I have 90% confidence that your score is between 50 and 100. And this is based, guys, probably on my experience with the first test, probably. So 90% is a high confidence level, but it's not a 100% confidence level. I could make a statement, I'm 95% confident that your score, your average score on the test, on the second test is gonna be between, let's say, 40 and 100%. Probably from my experience, no students got below 40, so I could boost my confidence and say 95% confidence. There are also some other confidence levels, guys, but they're not used much. The lowest confidence level that we use is the 90%. And then we use the 95% confidence, and we use 99% confidence. The 99% confidence, like in medical research, pharmaceutical company, when they present any studies to the FDA for approval or any new medication, it has to be done at the 99%. They have to have a very high confidence level, otherwise their studies will not be accepted. There is also 80% confidence level. It's a low confidence level. It's used sometimes, but most of the confidence levels that we're going to be using in this chapter are the 90%, 95%, and 99%. There is no such a thing, guys, called 100% confidence level, because in order to be 100% sure, you have to have the entire population surveyed or taken into account. And that's not going to happen, because we're always going to collect samples, not the entire population. So I could make a statement, I'm 90% confident that the proportion of students who get an A in my class is between 20% and 40%, probably based, just on previous experience. Or I could say I'm 90% confident that more than 70 or 80% of my students are gonna pass the course. But I cannot say I'm 100% confident, guys, that more than 70 or 80% of students are going to pass the course, because I really don't know. This is a fact. When I say 100%, I'm making it a fact that this is happening for sure. But when I say 90%, I'm allowing a 10% chance for a room of error. So that's why the confidence level can never be 100%. Okay, so this is about the confidence level. So I'm going to take you now into the details and how we're going to construct this interval. I'll be talking a little bit, so bear with me until I'm done explaining this, guys, and then you will see the process is very straightforward to construct the interval, whether even you do it by hand or by using the calculator. So let's say we survey 20 students, and we ask the person who surveyed the students to ask him for their age, and we did a mean age, X bar, let's say it was 21.2 years. So that was from the sample. This is sample average, guys. Please, sample mean. Keep that in mind. But let's say later we went to the college, and through their records, they were able, to pull the actual mean of average age of students, because they have a database that has all the names, all the ages. So they did an effort. It took them, sometimes it takes a lot of work, guys, to figure out the average age of all students. It's not an easy task. So they did that for us. This is usually not possible, but let's assume they were able to do it. And they came up with this. They told us that the actual average age is 22.3 years. So that means we missed. We didn't get the actual age. What do you guys call the difference? This is the estimated age, and this is the actual value. What do you know what we call the difference between the actual value and the estimated value? Any person? I'm sure you've heard of the word. When you estimate something and then you get the actual value, the difference between the two, if any, is called what? Any ideas? It starts with the word margin.
Margin of error.
Margin of error. The margin of error, guys, is the difference between the actual value and the estimated value. That's what the margin of error is. They call it in the book E. If the margin of error is 0, guys, that means the estimated value is exactly the actual value. It will never be 0. There are always going to be the margin of error. I'll tell you how you can reduce the margin of error, guys. The larger your sample size, the smaller the margin of error. Because when you have, just a larger sample size, that means you have a better representative of the population. When you have a better representative of the population in the sample, your chances of making errors are going to be lower and lower. But you will never get a margin of error E equal to 0 unless if your sample is the entire population, and this is not going to happen. So there will be always a margin of error. Okay, here's how we're going to construct an interval, guys. They're going to give us a sample size. They're going to give us a sample mean, X bar, and they're going to ask us to find a confidence interval for the population mean. Well, I know it's not, the interval has to start with a low value and go to a larger value. I know my actual mean could be a little bit lower than X bar, or could it be a little bit more than X bar? So my interval, guys, look, what is it gonna be? It's gonna be an X bar minus the margin of error, or between X bar minus the margin of error, or X bar plus the margin of error. This is X bar minus E. It's called the lower value of the interval. And this is the upper value. So when you find the interval, guys, you will be given X bar. Your task is only to find E. And once you find E, you do X bar minus E, X bar plus E, you are done, and you have what we call a confidence interval. Now let me show you how to find E. I told you that X bar minus the mean, it's called the margin of error E. Now I want to take it to a formula that we did in chapter 2. Z equals X minus mean divided by sigma. But remember, guys, we're not working with one value here. We're working with X bar, so with a sample of size N. So if I change this one to an X bar, can a student tell me what else have to change in this formula? So if we're not working with one value, we're working with X bar, what else will change based on section 5.4? Any ideas? Yeah, the sigma, exactly. It will become sigma over square root of N. Okay, watch, guys. I'm gonna do cross multiplication. So Z times sigma over square. Don't worry, you don't have to memorize any of this. They will all be provided for you, the formulas. So what I did, this times that equal X bar minus mean times 1. Okay, now watch, guys. The X bar minus the mean, I told you it's called E. So E is Z times sigma over square root of N. Here's the formula for E. Now, this will be given in the problem. And the sample size will be given. So what else do you need you guys to know in order to find E? What's missing?
Z.
Z, exactly. And Z is based on the confidence level, which will be given to you, the confidence level. So all I need, guys, to show you how to find Z, and I'm done, and then I can show you how to create an interval. So look, guys, where we are right now. Just bear with me, guys. We're almost there, and then we do some practice. X bar plus Z times sigma over square root of N. So this is given, always. This is given. They'll give you either sigma or S. We're gonna begin when sigma is given. And this is N given, given. So the only thing is to show you how to find Z. So let me now show you how to find Z based on the confidence level, guys, and then I'll go back to the handout and show you how to construct the interval, both by hand at first and then by using the calculator. So let me show you how to find Z. Let's say he gives us the confidence level to be 90%. I told you, you're gonna see in the book, the common confidence levels, guys, are 90, 95, 99. There could be 80%, but you will be able to work with any confidence level, and your calculator will take any confidence level, but these are the common ones. I'll show you the table in a second also, where he lists his 4 confidence levels in there. Here you go, watch. You see, guys, based on the confidence level of confidence, he tell you what Z is, and that's what we're looking for. So since I'm doing the 90% confidence, you know the Z has to be 1.645. I'm going to show you how to do this both by hand and by using the calculator. You can also try to memorize, you know, those three values. I always ask students to try to memorize the values of Z for 90, 95, and 99 because they pop up all the time. But let me show you how to do this. Okay. Okay. So we have 90% confidence and 10% non-confidence level. So this is your 90%, guys. You agree with me? It should cover the entire area right here. Let's see if any questions here. Okay. This is 90%. This is Z line. This is the 0 right there. And okay. So if 90% is for the confidence level, what is left, guys, from the entire area under the curve? 90% is our confidence. What's left?
10%.
10%. And you guys, you should agree with me that the 10% is split across the both sides. This is a 5%. This is the 5%. Now, the number that splits up the confidence region from the non-confidence region is Z that I'm talking about, and they call it in the book a critical value. They call it Z sub C. C stands for confidence level. There is a negative part of it. There is a positive part. It's enough to find one, guys, so you know both of them. Who can tell me using the inverse norm how to find ZC? What is ZC, guys? That's chapter 5 now. I need to find this number. I know the area to the right of it is 5%. So what would be the number? What do I put here, guys? We need the area to the left. So what's the area to the left of this? Is 5% on the right? It will be
95.
95%. Excellent. And I'm going to show you a shortcut, guys, to do it. So it's a 0.95. And then you don't put mean standard deviation since you're doing Z. It's 0.1. Let's see if we're lucky, we're going to get 1.645. If I don't get that, I'm in trouble, guys. Let's see. Second, distribute, inverse norm, 0.95, comma, 0, comma, 1. Every time you work with Z, guys, it's 0, 1, always. There you go, 1.645. If you do this one, guys, you really don't need to do it. This is 1.645. This one should be negative 1.645. The area to the left is 5%. So let's do it. Second inverse. Watch. You're going to get the exact same thing. Negative 1.645. So this is how you find the critical value, which is called Z, critical value. And C stands for confidence level. That will always be given to you. So we found Z, guys, now we can find the interval. But before I move to an actual exercise, I'm gonna change the confidence level and do some practice with you on the calculator and how to find the critical value. So let's say the confidence level now is 95%. How do you find ZC? I'm not gonna sketch, I'm just gonna give you the shortcut and how to do it. Okay, help me out, guys. We need to find only one and that should be it. I'm gonna show you the shortcut for the easier one. Look what you do, guys. Subtract 95% from 100%. What do you get?
5%.
Divided by 2.
2.5.
That's it, that's all you need. Change it to a decimal. What is 2.5% as a decimal? 0.02501. So 100% minus 95%, 5%, 5% divided by 2, and you're done. Just put it here. You're gonna get the -1, which is okay. Negative or positive, it doesn't matter. That's a critical value. And if you do the math, guys, you're gonna get -1.96. And if you see here, watch, guys, 95%, it's 1.96, but you just use the positive part of it. But you can do the negative part, no problem. For 99%, and I'll demonstrate this on the calculator. Okay, help me out. Exact same thing as I did before. So you subtract from 100%.
1%.
1%. Divide by 2, don't forget that, which is going to be 0.005. So your ZC is inverse norm 0.005, comma 0, comma 1. It should be 2.575. Let's see. I'll do it. Watch, guys. There you go. 2.576, and that's what you have in the table at the bottom. You get negative, but as I told you, just use the positive part of it. It doesn't matter. Okay, let's do one more. I'm gonna change the C to, let's say, 94% confidence. Okay, how do you find the critical value? 100% minus, you're gonna see, guys, I'm consistent here. I don't change what I said. I always do the same thing. 6%, divide 6% by 2, 3%, and look, ZC is inverse norm 0.03. So in the homework online, if you're asked to find the critical value, guys, this is how you do it. You don't have to use the table. I'm giving you a better shortcut than using the table, guys. All right, so let's see. Second and inverse norm, and then 0.03, watch, comma 0, comma 1. -1.88. If he asks you in the homework to find both the critical values, the positive and negative, so one is going to be -1.88 and the other one would be +1.88. Now I'm ready, guys, to go back and show you how to construct an interval. Okay, so this is how you find the critical value. As I told you, this is the key. And then let's go back. All right, we'll continue with this. 4, number 4. The sample mean X bar is 57.4 and the margin of error E is 4.5. Write the confidence interval for the population mean. So here is the population mean formula, guys. It's between X bar minus E and X bar plus E. So we're already done here. He gave me X bar. So here he's not asking me to do any work actually. Minus 4.5 and then mean 57.4 plus 4.5. Remember, the plus is on the right and the minus is always on the left, guys. So the mean will be, if you subtract, it will be 52.9, between 52.9 and 61.9. Okay. Now, guys, this is probably a kind of tricky question. If I give you the confidence interval, can you tell me what the margin of error is? How would you do it? Look, this is the formula. Mean is between X bar minus E and X bar plus E. If you are given the confidence interval, how would you find the margin of error? Any ideas? what would you do? You got to do something with the lower limit and the upper limit. Any ideas, guys? X bar plus E minus X bar minus E. It will be X bar plus E minus X bar, and minus with the minus, guys, will be plus. X bar minus X bar cancels out, so you get 2E, which is 178 minus 167. That's 2E. So you subtract, and then in order to find E, you have to divide by 2. So it will be 167 minus 178, which is 9, divided by 2, which is 4.5. So guys, when he gives you a confidence interval and he asks you to find the margin of error, you subtract the lower limit from the upper limit and divide by 2. But if he gives you a confidence interval and asks you to find the mean, you add them up and divide them by 2, the sample mean. So let me just add this here. For X bar will be equal 167 plus 178 divided by 2. Which is what, guys? 167 plus 178, and then divide by 2. 172.5. That is X bar. Okay. 94% confidence, guys, we just, I think, did it earlier, but I'm going to do it again. So here's what you do. You do inverse norm. Subtract 94 from 100, you get 6%. Take half of 6%, it's 3%. 0.03, comma 0, comma 1. 98%. Can a student tell me how to find the critical value for 98%, please? What goes in here?
$2.
And then what do you do with the 2%? Divided by?
2.
Exactly. So that would be 0.01, comma 0, comma 1. Okay, question 8, guys. What happens to the confidence interval when we increase the confidence level? Does it become narrower or wider? Look, I can say I'm 100% confident, guys, that your scores on the test will be between 0 and 100%. But if I say I'm 90% confident, what's going to happen, you know, just to the lower and the upper bound of the interval? Are they going to shrink, or are they going to be even wider? Any ideas?
Be wider.
They will be shrink. That's so when you increase the confidence level, guys, your interval will widen, because you have to allow for more options. So there is no really real winners here. We always want a high confidence level, but it's going to be at the expense of the interval. The interval is going to become bigger. And you cannot go too low with your confidence level to make your interval narrower. So you got to figure out a win-win situation. When we increase the confidence level, the confidence interval widens. Means the lower limit becomes smaller and the upper limit becomes larger. And if he asks you what happens to the confidence interval when we decrease the confidence level, the interval will become narrower. And you will see that, guys, when we do the calculator. You're going to see the 95% confidence interval is a lot wider than a 90% confidence interval. You will see that. Okay, so let's go to the next part. What happens when we increase sample size? Okay, what happens when we increase sample size, guys? It's a great thing to be able to increase sample size. And remember, your margin of error is based on the sample size. It's this formula. Less error, that is correct. So the margin of error will become smaller and your confidence interval will become also narrower when you increase the sample size. It's always a good thing. You don't want the confidence interval to be so large, because if I tell you, oh, you're gonna score between 70 and 95, what kind of news did I bring to you? It's still, it could be a C, it could be a B and an A on what I said. So that's a wide interval. But when I tell you your score, I have confidence that your score is gonna be between 88 and 95. This is a small interval. I'm telling you, it's either a B plus or an A. So you can see how narrow the interval is here. What happens to the confidence interval when we decrease the confidence level? It decreases, it becomes narrower, but the confidence level is low, which is not accepted sometimes by many people. All right. Now we're gonna hit section 6.1, guys, and we're gonna show you how to construct a confidence interval. So let me give you a definition of point estimate. If you wanna do estimate in a hurry, the population mean, we use the sample mean. So to estimate, but this is not a very accurate estimate. That's why we need the confidence interval. To estimate mu, find X bar. Better than nothing. But if we can do a confidence interval, it will be even better. And I'm gonna show you how to construct a confidence interval. I will begin with example 2, guys, before example 1, because example 2, I put steps there so I can walk you through the steps as I do this. Okay. Construct a 95% confidence interval for the population mean. Assume that the population has a normal distribution. A sample of 25 randomly English majors. So N is 25, guys. This is the first example where you learn how to construct intervals. Has a mean test score of 81.5 X bar. Assume that the population standard deviation is known to be 10.2. So population here, standard deviation. You guys cannot put S in here. It is sigma. He says population standard deviation is known. And actually 60.1, guys, is about sigma known. Let me show you the title. Estimation for the mean of a population standard deviation known. So in section 6.1, guys, is gonna give you a sigma instead of S. Please keep this in mind. So sigma equals 10.2. And he says 95% confidence level. This is the 95. Okay, I'm ready to show you how to construct the interval. First of all, find the critical value, ZC. Using table 4, I'll show you how to do it using table 4, but let's do it using the inverse norm. So can you help me, guys, with the inverse norm? And you can memorize it, actually. So we got 95%, we're gonna subtract from 100, we get 5%, split it by 2, it will be 2.5%. And this is gonna be the 1.96, guys, negative 1.96. You could do this, or guys, it is right here. Let me show you. 95%, it's 1.96. Or you take the 2.5% and look it up. What did we do here? So we took the 0.025, the area, and see if you can find it in the table. It's gonna be, let me show you where, guys. 0.025. Look right here, if you can see, and if you try to figure out, you know, just what the z-score is, it is negative 1.96, the 0.025 right here. Look, this is the 6, and this is the 1.9 right here. But you can use the calculator, guys, anytime. So if you don't want to use the table, that is fine. You're going to be provided with the table when you do your homework online, but I would use the inverse norm feature. It's faster and easier. Somebody asked me about why the z-score is negative. No, we always use the positive part. Even if we get a negative answer, you just use the positive part. Because one time you're going to subtract E and one time you're going to add E. So it doesn't matter whether you use a plus or minus. Calculate the margin of error, guys. So watch me doing the margin of error by hand, and you will see how the calculator is used. ZC is 1. I'm going to take only the positive part of it, 1.96 times. What is sigma, guys? 10.2. And divided by square root of n. And let's do this together. Technically speaking, once I'm done with one interval, you're gonna see, guys, that everything will just gonna be pretty much the same. So it will be, let me turn the calculator on, 1.96 times 10.2 divided by square root of, what is n? 25, which is 5. So I got 3.9984. If you round it, guys, to 2 decimal places, it's going to be about 4. So let me just put 4 here. Okay, let's go to the next page and write the interval and interpret it. Write your interval. Mean is, what was X bar in the question? It was 81.5 minus 4. And look how easy it is, 81.5 plus 4. And the mean will be 81.5 minus 4 will be what, 76.5? Or 77, sorry. And here just add 85.5. That's the interval. Now, this is how we interpret the answer in words, guys. Even when you do your work online, he's going to ask you to write a final statement, select a final statement. So this is what you say. You say, with 95% confidence, we can say that the true mean of, what was the problem about? Okay, simple. Okay. The true mean of English majors, I'm just copying it from the book. The true mean score of English major is between, already I have a between in here, 77.5 and 85.5. I don't need this. Okay, now let's do the calculator and show you how we could have done this on the calculator. I provided details on the calculator on the last page using TI-84. You ready? Okay. When you want to find a confidence interval for the population mean, and when sigma is known, we use what we call a Z interval. And let me show you how to find the Z interval. From now on, guys, most of your work on the calculator, probably till the end of the semester, is going to be in this location. You're going to click on stat. You're going to click on tests, not calc, not edit, tests. And I said we're going to do Z interval. It's number 7, guys. Watch. Okay, let me interpret this. It says, what's your input? Is it from raw data set or from a summary? Well, he gave me a summary, so it's stats. So it's by default at stats. Then he asked me about sigma. What was the value of sigma? And sigma was 10.2, guys. Then he asked me for X bar. X bar is what? What was X bar in the problem? 81.5. Oops, what did we do here? Stat. There's weird characters in there. They cause this trouble. Let me just try to erase them. One second. I need probably to. Okay, so stats. Sigma is 10. What was it? 10.2. X bar is 81.5. N is 25, guys. And the confidence level, you can put 95 or 0.95. It doesn't matter. The calculator will pick it up. And watch, guys. Works like magic. 77.5, 85.5, and that's what we got. This is the interval. Even when you use your calculator, you still have to interpret the answer. So you have to say, with 95%, you can say confidence, you can say that the true mean is between 77.5 and 85.5. Why do we have to say this statement? Because for a reader, you're not going to tell him that the mean is between 75, 77.5 and 85.5, because actually probably it's not. With 95% confidence, we think it is, but not with 100% confidence. Any questions about this, guys?
Wait, so how did you get to the Z interval thing?
Okay, let's do the Z interval thing one more time.
All right.
So you go. Let's do it together, guys. Click on stat, everybody. And not edit, not calc. Scroll to the right to tests. And then it's number 7, guys. So for section 6.1, it's number 7. We use the interval when he gives us sigma. Sigma is known. And if I take you back again, that's it. Even in the book, guys, when he give you a problem and asks you to find the interval doing that table, etc., you can refrain from using the table and just use the calculator. And again, the explanation when you click on help me solve this or view an example, it's very likely it's not going to be technology. He's going to show you the work by hand. But if you're attending today's lesson or view the video later, you're just going to grasp the idea of using the calculator and apply it. Please do. That's going to save you tons of time. You can't believe how much time you will save when you use the calculator. All right. Now let me do one more example. I'm going to go back to the first example, guys. I'll show you how we can do this one. Suppose a random sample of size 49. So N is 49. We find a sample mean of 30. X bar is 30. It is known that the typical distance value is from the population standard deviation is 35. So the standard deviation is 35. Construct Okay. Construct a 95% confidence interval for the population mean. Okay, let's do this, guys, first of all on the calculators, just to give you a feel how easy it is to use the calculator. Let me see if any questions. Okay, you got it? Okay, great. Now let's do it, guys. Watch. And he wants a 95% confidence interval. Let's see. That's all you need. You need to provide n, you need to provide x bar, you need to provide sigma, and you need to provide c. Once you have them, you can use the calculator and watch, guys. Go to stat, tests. It's under tests, guys. From now on, chapter 6, 7, 8, 9, 10, all the way. It's under here. Z interval. When do you use data? You use data when he gives you raw data set. You have to enter, do data entries. You put him in L1, but not in this case. So my sigma, guys, is 35. My X bar is 30. My N, he says it's 49. And my confidence level is 95. Okay, that's all I need. So the mean is between 20.2 and 39.8. Look, it is $30 plus or minus 9.8. And if you do that, you get 20.2 and 39.8. How do you interpret this statement? You say with 95% confidence, we can say that the true mean is between 20.2 and 39.8. Now you want to see, guys, how this was done by hand. X bar, and this is E, to find E. How did he find E? ZC is 1.96. You can memorize it from now. For 95% confidence level, ZC is going to be 1.96. He put the standard deviation, which is 35, and divided by square root of 49 to find E, guys. And that is what we did to find E. Any questions? All right. So E here, it's going to turn out to be, guys, 90.8. And let me show you why it is 90.8. ZC sigma over square root of n. 1.96 times 35 divided by square root of 49. And if you do the math, you will get 9.8. So you do 30 minus 9.8. I hope that you guys understand what the plus minus means. It means you add and then you subtract. That's what it means. I just put an abbreviation here to show you the math. So this is the confidence interval for the population mean when sigma is known. We got one more thing and we'll wrap this up for today. Any questions? Okay. One more thing, guys, and we'll be done. You're gonna see section 6.2 and 6.3 tomorrow are not gonna take much time because we're spending time on this, so it will be very easy. You will see that. I can promise that. If you grasp 6.1, I can promise you that you're not gonna have issues with the remaining two sections. It will be easier even. All right. An insurance company is trying to estimate the average number of sick days that full-time food service workers use per year. A pilot study found that the standard deviation to be 2.5. So that's sigma, guys. How large a sample must be selected if the company wants to be 95% confident, that's C, of getting an interval that contains the true mean with a maximum error of 1 day. So he says, how many should be included in the study so that the study will be a reliable study and the maximum error will be no more than 1 day. So they want to minimize the error. Remember, guys, the lower the error, the larger the sample size. So they're saying we're allowing an error of 1 day. How many should we put in the sample in order for our study to come out so that the maximum error will be no more than 1 day? So this is E, guys. And this question here, he wants the sample size. N. Let me show you how to find the sample size. Here's a formula I did earlier with you. Now, guys, I want you to help me with your algebra skills. I want to solve for N. What do I do to solve for N? I'll get started. Let's do a cross multiplication. So E times square root of N equals ZC times sigma. Okay, what's the next step, guys, in order to solve for N? That's algebra, not statistics anymore. Think of this as a formula and I'm trying to solve for N. What do I do next?
Plug in the numbers.
What is it? Divide by E? Let's divide by E here. And I got square root of N equals ZC. Again, guys, this formula will be provided to you. You don't have to memorize it. And how do I do N, guys, if I know square root of N? What do I do now? Last step. Square both sides. If I square both sides, I get this formula, guys, which is right here. You can see it. Okay. We need N equals. Watch, guys. Very straightforward. Who can tell me what ZC is for 95% confidence? You should try to memorize it by now. What is ZC for 95% confidence? Yes, 1.96. Very good. Everybody try to memorize this. There's 3 of them, most common ones. Sigma, he gave it to us. He says it's 2.5. And margin of error is 1, guys. So just let's do the calculator. Don't forget to square. The mainly common issue that I have with students when they find the sample sizes, they forget to square when they use the formula. So 1.96 times 2.5. Okay, and now we need to square it. Okay, 24.01. What do you think the sample size? Remember, the sample size is a whole number. So what's the sample size?
Would it be 24?
Is at least one student says 24. Do you guys agree? Unfortunately, 24 is going to fall short. You always have to round up because it's 24. You need a 24.01. Even if you guys think that 0.01 is nothing, in order to get, just the 1 day margin of error, it has to be a little bit more than 24, but there is no 24.5 person or a quarter of a person. So you always round up.
Even if it's 0.1, we round up that.
Even if it is 0.0001, if you have to always round up. I mean, the 24 might work, but it's not going to give me the 1 day. It might give me 0.99 day, but if he wants the 1 day, it turns out to be a decimal go up. If this was 24.9, guys, you go to 25 as well. Same way. So always round up. Unless if you get the whole number, no decimals, you don't round, you don't do nothing. But if you get a number, please round up. And it is 25. So with this, guys, I'm done with section 6.1. Please try to do some practice on it before tomorrow's lesson. And you're going to see section 2 and 3. We're only doing 2 more sections. It's going to be a breeze if you had a decent grasp of today's lesson. If not, we're going to do more today. I'll do some more review of section 6.1. So tomorrow, before I start sections 2, I'm going to do a review sheet with you, which I'm going to send along your way today. And remember, guys, anything I send you will be available under instructor by resources by your instructor. So